Hello everyone, welcome to a longer training session for the prototype series video, creating 2D magic spells. In the original prototype series video, we showed you how we implemented a fireball projectile, but also the ability to raise the ground using the sprite shape feature. I think this turned out to be my favorite spell from the video, and it's cool because you can actually change the interaction of the environment because by changing the sprite shape, you also change the shape collision. So in this video, I want to go a little bit deeper on specifically this spell and how we made it. So as mentioned before, the entire terrain is using sprite shape. And actually, the Lost Script demo uses sprite shape not only for the ground that the player walks on, but also foreground, background, and all these different things. But the one that we actually want to change is the one that has the edge collider. Of course, that allows us to collide with the ground. And of course, the collision automatically follows the shape of the sprite shape. So one thing you may have noticed in the start of the video is that when raising the ground here, too much of the terrain would actually go up. And in the sprite shape, this happens because there aren't enough nodes. And nodes are basically these controllers and actual vertices of the sprite shape that you can basically select, modify, change the handle to make it look your own, right? But the idea here is that if I raise the ground here and there aren't enough nodes on its right and on its left, it will basically interpolate the values from the latest node and the next node, right? So one thing that we actually did in the project was to just create extra nodes to create a better segmentation. So this would mean that when we found a node in our code and raise it, it will be a little bit more segmented. So this means that, when you're using the spell, you sort of know exactly where you're clicking and what you're raising. So let's go into the code here and see how we exactly achieve this. So in the environment game object, you'll notice that we created a dedicated script just for modifying the sprite shape, and this is called the environment controller. And here we're making a reference to the sprite shape. In our case, we only needed to make a reference to one that we knew that we wanted to modify. But if you're making a project in which you need to know which sprite shape you want to modify, you can do this by many ways, by using raycasts, collisions, or even triggers, right? But we're using just one in this case. So how do we actually activate this? So if we go into the environment controller and see our public function that we created here to manipulate the actual points of the sprite shape, you'll see that we have one reference, and that reference is in the character controller. So the character controller is a script that came with the Lost Script demo, but we added functionality to detect both the left and right buttons from the mouse. And for our second spell, we're using the right button. As you can see here, we're calling the environment controller and we're calling that function that I just mentioned. The only information that we're sending here is that we're sending a vector3 variable called screen position. And the screen position is just basically using the function screen to world point to convert the mouse position from the input system to a world position that we can actually use. So let's get back into that function from the environment controller. So what we needed to do here was to take that mouse position that we sent into the app_point function and basically find its local position relative to the sprite shape. For this, we created a new vector3 variable called endPosition and used the inverse transform point function to again find where that world position is relative locally to the sprite shape. Then we basically set the node integer to 0 because we don't know which node is it yet, and the distance, which is a float variable, we first set it to infinity because all of this is going to be set here in our for loop. So what is going on here on this for loop is that we're going through all of the nodes in the sprite shape, and then we're setting a vector3 variable to store the position from the node from the current iteration. And then we're also storing a temporary distance float variable to check the distance between the end position, which we have set before, and the current point position from this iteration. And then we do a check to see if the temporary distance is smaller than the distance that we have set here. And the interesting thing here is that if that is true, then that distance that we have set before will be overridden by the temporary distance. And the actual node that we're modifying is going to be set for this current iteration. But then every time this loop goes on, if the temporary distance is smaller than the distance that we now have set, it will override the information, and then basically we will find the closest node to the mouse position. With this information, what we can basically do is set the start position from the current node that is closest to the mouse position, and then we also have the end position. So now it's just a matter of interpolating the start position to the end position. And for this particular interpolation and sort of animation, we're using the DoTween plugin. And DoTween is a plugin made by DemiGiant that has a free version, also a pro version, that is an amazing way for you to easily tween values of position, rotation, and create, amazing animations in very simple lines of codes. So really recommend it. But basically, we're here creating a sequence that allows us to animate our position from 0 to 1, which in this case means that we are lerping from the start position to the end position. And this will basically create the effect of the node being moved from the start to finish. So if we take the simple behavior that we've done, you'll see that basically the values interpolate from the start position to the end position. Using DoTween, of course, makes the animation smooth, but there isn't much of an impact to the action here. So it doesn't feel as powerful as it should because you're basically bending the ground. But just modifying this might not be enough. So there isn't enough polish here. So I actually want to go through a little bit of what we did here to enhance the polish for this specific spell. So as you can see here in the code, I have commented some of the stuff I have done to improve the feel and the actual polish. The first thing is the particle. And the particle, what we're doing here is we're taking one common particle, moving it to where the first thing here that was commented is the actual particle emission that we have created. And so you can see here that what we're doing is we're setting this common particle position to where the position, god damn it, sorry, I apologize. So the first thing here was the particle that we have commented, and this is the thing that we have done to enhance a little bit of the effect. And so you'll notice here that what we're doing is we're setting the particle position to be the same as the start position, and then we're playing the particle. Now let's take a look at how this particle looks. And so you'll notice here that I made this particle be a child of the sprite shape because we're using local position, and it's just easier for it to be a child of the sprite shape. But here's the thing. To create this particle, I have created a set of one main particle and two sub-emitters. So I actually want just to remove some of these sub-emitters to show you step by step which are the particles. The first one that we're using as a base is the spark one, right? The spark one is a simple emission that instead of using rate over time, it's just doing a big burst of 60 particles and having a very short lifetime, quick speed, and so it does this cool effect, right? But by adding sub-emitters, which you can see here in the sub-emitter tab, you can see that we can add other particle systems that will automatically be activated once, for example, you can set Y, but in this case, once the particles are born, right? In this case, they show up. And so the first sub-emitter that I have made here is a smoke one, if I'm not mistaken, yes. And the smoke one is the one that we are using a texture sheet animation, which basically takes an image, and I'll show you right here what I mean by that. It takes an image like this, that is an animation frame by frame on a grid, and what we can basically do is tell the particle, hey, start here and start moving horizontally and then down to basically create this animation. And so using the texture sheet, let's just go back into the sub-emitter here. You can see that we can do this by activating the grid mode and telling the size of this actual tile. So by using that, you can create animations, and you can see here that these are individual sprites. If I turn that off, you'll notice that it kind of just instantiates the whole grid. But if we use this, of course, then it's going to animate as if it was actual smoke. And this is pretty cool. And then the last one is actually pretty similar to the spark. The only difference is that I created a material that sort of has as a sprite a I think it's actually a texture from one of the trees, but it is so small that it just seems like normal grass. And it's just a burst that goes smaller and then slowly fades away. And a combination of these three particles already, creates a nice effect. And so the second thing that we're doing to improve the visual in general is that we're using a point light 2D. And what we wanted to do via code was to bring the intensity from this light really up to then bring it back immediately, creating a quick flash effect that would really improve the particle emission. So back to the code, you can see that what we're doing is we're taking the position from this environment light and putting it at the same position as our starting node. And then we're using doTween again to lerp the environment light intensity from 0 to 6. And once that is done, we just do 6 to 0 to create a really quick flash effect. So as you can see here, the lights make the spell look much better. It makes sense for the particle emission to be followed by a light emission because we're using sparks, and in general, this really gives the impression that this is an actual magical spell. So this is looking pretty good, but this could look, of course, even better. And that, of course, is by adding screen shake. And with Cinemachine, it's really easy to just add some impulse to our camera. In the environment game object, which is where the environment controller script is, I also added an impulse source where I can determine the amplitude gain, the frequency, and even the sustain time of that shake. And so I can basically determine how the shake from the second magic spell is going to look like. All we have to do is that we have to make sure that our virtual camera has a impulse listener. So if our virtual camera has an impulse listener, from whatever object you do an impulse source, so you generate an impulse, they'll basically quote unquote listen to it. And so the result of all of this is that this spell now seems and feels super powerful. In fact, it feels so powerful that we decided that once that touches the enemies, it destroys them immediately. So this really helps to improve the game feel, and it just looks polished in general. So if we're bending the earth, if we're modifying the earth, it makes sense that this is super powerful, and you would feel in real life sort of like this powerful impact. So it makes sense that you have a screen shake. And in general, the particle system, the light, and the screen shake really improve the feeling of this mechanic. So basically, this is how we access the API from the sprite shape, and also some tips on how we made the actual spell feel a little bit more powerful. And I really hope that this was useful, and I actually am really interested to see what people can come up with by modifying the sprite shape and just seeing what they do with the new 2D features in general. Thanks for watching, and I'll see you in the next one.